we will discuss in functions, and we will pick up where, from where we left off. We discussed about the injective, bijective, the surjective. One, two, three, four. These are this is setups. This is setup. A, B, C, D. E. 1, 2, 3, 4. A, B, C, D. 1, 2, 3, 4. 5. A, B, C, D. The critical word that we should remember while defining injective functions is that if each element of y, this is domain, this is a domain. If each element of y is mapped to from one element of at the most one, meaning here you cannot map two elements of x to an element of y, and the wording is at the most one. Right? So 0 will be is less than 1. So 0 is okay in the sense there can be an element which is not mapped from any x element to, that is the injective function. And also mathematically, how we can represent that for x, for every x and x prime belonging to x, as x is equal to x prime implies that x equal to x prime. So there cannot be more than one element of x that maps to any element of y. 0 is fine in the sense there can be an element which is not mapped to any element of x, mapped from y. So that's the definition of injective. Now we come to bijective. Right? So what you should remember is at the most one. That's the critical rule. Now we come to let us go to surjective, because there is a difference between this and that. This is surjective is kind of an extension of this. When we discussed functions, let's say x is input, we give x as input to a function, right? Function. Output, it gives output y and output. Right? When we give any what we call this argument or variable, the element belonging to x is called variable. Here this is called image. Image or this is function, of course. That is variable, this is function. Okay? So when you give x element of x as input, you get element of y as output. So this is called, each is called image, and set of images, these images is also called an image. Okay? And as we all know, this is domain, this is no domain, and the elements of y are mapped to from elements of x. So what is the difference between this and this? Here, it is amount to map from two elements of x to one element of y. That is a surjective. Meaning, this is also called, this is called one-to-one function, injective. This is called on-to function. So in on-to, the correct word, the critical word is at least. At least these elements should be mapped at least from y. Y should be mapped from at least one x element. Right? That is the definition. When that happens, this, as I told you, this is a set of images, all of these, which are mapped from X, and this is a codomain. When will this happen? At least one element of X is mapped. This, when it will happen, when this codomain, the image is equal to codomain. Image, it is, which are like elements mapped from X, A, B, C, D, or should be equal to codomain. Meaning, you cannot have X be here. You can't have an element which is not mapped to from X. There should be, each element should be mapped to from at least one. And when we say at least one, this is greater than 1. Meaning, you can have 4 and 5 can map to single D. One element of it. That's the basic difference of what is called injective. At the most one, at least one. Right? So that is basically, and then will not happen. That will happen when the number of images are the codomain, the entire codomain is mapped to. This is also called on-to function. Bijective, and let us see how we can notationally how we can write surjective. For every y belonging to y, the set y, there exists, there is no symbol, here we come across, there exists an x which belongs to x. And of course, y equal to. Again, for every x here, for every y here, element in y here, there should exist an element in x. We can't have elements in y which are not mapped to x. That's what this mathematical The third one is bijective. Now, here the critical terminology involved is each of this element from Y should be mapped to a distinct element, distinct as a keyword, as at the most for injective, at least for one from of the subjective. Here, the keyword is distinct. Each element should be mapped from a distinct element. Like mathematically, how we can write that? Let us see. Mathematically, for every y belonging to y, there exists, be careful here, this is critical, basically, there exists, followed by an asterisk sigma, value in that exclamatory symbol. Here, the exclamatory, here, there exists, is this symbol. So, there exists exactly 1. This means exactly 1. Exactly 1 x belonging to x. Okay? And of course, they are related by the function. Let us see these mathematical notations yesterday. They are very, very important. And whenever we look at it, and the bijective is also called 1 to 1 correspondence. This is 1 to 1 function, this is 1 to 1 correspondence, this is 1 to function. We should explain these things there. There's no other one. Okay? Yeah. Now, let us go back to so I wanted to discuss here. I don't think here. Let us see. Let us go back to functions again now. Functions.